So we did the inequalities with and, now we're going to do them with or. So remember, both things don't have to be true, but at least one of them has to be true. So it says solve the compound inequality, graph the solution, write the solution in interval notation. Okay, so we take each part separately. We're trying to solve for x, so I'm going to subtract 1 from both sides. Negative 2x is less than or equal to negative 4. And then I'm going to divide by negative 2. And because I'm dividing by a negative, I'm going to have to switch the inequality the other way. And I get this statement, x is greater than or equal to 2. If I were to look at the graph of that, it says here's 0, here's 2, and I want x to be greater than or equal to. I want those numbers that are greater than or equal to 2. All right, now I'm going to take the other statement, 7 plus 3x is less than or equal to 4. I'm going to subtract 7. I get 3x is less than or equal to negative 3. Divide by 3. I am not dividing by a negative number, so I won't switch the inequality. It's the act of the number that you're multiplying or dividing by. That's what switches the inequality, but we're dividing by a positive 3. So x is less than or equal to negative 1. So here's 0, here's negative 1, and with those numbers down there for that part. Now, if I look at it, you know, here's my 0, here's my negative 1. If I stack it, there's no overlap in this case. That's okay. We just need the numbers that are either less than negative 1, so things like negative 5, negative 6, or they're greater than 2, like 3 and 4 and 5 and things like that. Okay, both parts don't have to be true, one or the other. And so what we do is we join these two sets. So I need, if I were to highlight the numbers I'm talking about all these numbers and all these numbers, okay? So it's almost like everybody gets to be in the set, except I can't have like 0 and 1 and 1/2 and the numbers that don't fit one of the two situations, okay? And the way we write this is we go from left to right, so we're going to write this part first. So from negative infinity, remember negative infinity always gets a parenthesis, to negative 1. So we want to include all those numbers between negative infinity and negative 1. And then we have to use what's called a union sign. We want to join it with another interval. So it's like we want to skip over those numbers in between, negative 1 and 2, and then pick them up again at 2. So it's going to be bracket 2 to infinity. And so that's how it looks, a little bit longer to write, because we have two separate pieces of the number line that we're including. Okay, so I hope that works. And if not, we do another example. Okay, so here comes another example. So same directions. Okay, so we're going to add 8 to both sides. I'm sorry, we're going to add 7 to both sides. That probably scared you. All right, so I get 3/5 x is less than or equal to 6. Now, how do I get rid of that 3/5? We talked about this before in another video, but we multiply by the reciprocal. That's what we want to do there. It's positive because we want it to be a positive x. So on the left, what happens is the 5s are canceling, the 3s are canceling, we just get x is less than or equal to, now I can put that 6 over 1 if it helps. 3 goes into 6 2 times, and 2 times 5 is 10. So this time I'm saying x is less than or equal to 10. Okay. On the next one, let me show you something on this problem since we're kind of reviewing some of our solving skills anyway. Normally I would distribute, but I can get rid of that fraction. We call it clearing the fractions right off the bat. So what I can do is I can multiply by 3 here and multiply by 3 here, and then I don't have to worry about that fraction anymore. So I'd have 1 times x plus 6 is greater than or equal to negative 6. And then I can distribute the 1, because it might not have been a 1, but this time it's a 1. Okay, so I subtract 6 from both sides. And I get x is greater than or equal to negative 12. Okay? So this time, I didn't graph them, did I? Okay, so on this piece, it says, hey, we want all the numbers that are less than or equal to 10. So we want all those numbers. And then the other graph, I'll put it underneath so you can see it. Here's 0. Pretend like here's negative 12. I should have graphed it a little bit better. But I want x on the other part. It says or, remember this is an or statement, or x is greater than or equal to negative 12. Well, what numbers do one or the other? All of the real numbers do one or the other. You can't think of a number that's not either less than 10 or greater than negative 12. So we're going to include all the numbers. Sometimes I'll write all real numbers. But in interval notation, this is what it looks like. So what we want is we want all of these numbers and we want all of these numbers. And notice that they're going off in both directions. So that was try to be an arrow there. But it's going in this direction, it's going in this direction. Okay, so we want all the real numbers, and to write that in interval notation, we write from negative infinity to infinity, and that means all real numbers. So that's how it's written in interval notation. And I think that's the last example.